Stripe is a payments API that allows merchants to transact online. Since the creation of the payments API, Stripe has expanded into adjacent services such as fraud detection and business management and billing. And these other verticals leverage the existing customer base and infrastructure that Stripe has developed from the success of that core payments business. Raylene Yung is the head of payments at Stripe, and she joins the show to talk about her work, which includes elements of engineering, product development, design, and management. All of these dimensions of her job came up in our conversation, and it made for a wide-ranging discussion. This interview comes in the context of Stripe's rapid growth. The organization is changing, and Raylene explored the questions that Stripe is asking itself internally about org structure. Namely, what's the trade-off between a defined hierarchical structure of direct reports versus a decentralized, flat org structure? Raylene came to Stripe from Facebook, which is a famously decentralized, flat org structure. Another question we explored is the subject of highly defined roles versus less well-defined roles. So in the software industry, you commonly come across people who are titled Senior Infrastructure Software Engineer or SDE2. And these are pretty well-defined naming conventions that exist in a ladder of different hierarchically defined roles. And it's up for debate whether those are titles that make sense or if it's better to have people just have fluid roles like designer or software engineer, because then their stratification in the organization is less well defined and their position in the organization is less well defined, which can be good because maybe you want people to have fluid positions in the organization and have them self-assemble. These structural company questions are thought-provoking, and the fact that Raylene was willing to address them as open questions, I found that to be humble, and I found it to be a useful discussion. And if Stripe is having these questions, then certainly there are lots of other organizations that are also having these kinds of questions. So it was a really enjoyable discussion. Before we get started, I want to mention that we're hiring a creative operations lead. If you are an excellent communicator, please check out our job posting for creative operations at softwareengineeringdaily.com/jobs. This is a great job for someone who just graduated a coding boot camp or someone with a background in the arts who's making their way into technology. If you want to be creative and you want to learn more about engineering and you like Software Engineering Daily, check it out at softwareengineeringdaily.com/jobs. Citus Data can scale your Postgres database horizontally. For many of you, your Postgres database is the heart of your application. You chose Postgres because you trust it. After all, Postgres is battle-tested, trustworthy database software. But are you spending more and more time dealing with scalability issues? Citus distributes your data and your queries across multiple nodes. Are your queries getting slow? Citus can parallelize your SQL queries across multiple nodes, dramatically speeding them up and giving you much lower latency. Are you worried about hitting the limits of single-node Postgres and not being able to grow your app? Or having to spend your time on database infrastructure instead of creating new features for your application? Available as open source, as a database as a service, and as enterprise software, Citus makes it simple to shard Postgres. Go to citusdata.com/sedaily to learn more about how Citus transforms Postgres into a distributed database. That's citusdata.com/sedaily, citusdata.com/sedaily. Get back the time that you're spending on database operations. Companies like Algolia, Prosperworks, and Cisco are all using Citus, so they no longer have to worry about scaling their database. Try it yourself at citusdata.com/sedaily. That's citusdata.com/sedaily. Thank you to Citus Data for being a sponsor of Software Engineering Daily. Raylene Yung, you are the head of payments at Stripe. Welcome to Software Engineering Daily.
Thank you.
We've been doing a lot of shows lately on some different fintech companies. So we've talked to Klarna and N26 and just some other payments-related, fintech-related subjects. So I'd like to start at a high level. So like a developer who integrates with Stripe, that allows them to accept payments through their product. Walk me through the life cycle of a payment that gets paid through Stripe.
So it's almost hard to answer that question simply just because Stripe actually can do so much for our users. So we do a lot more than just allowing you to accept payments, and maybe they won't be too expansive, but the idea with Stripe is it enables you to essentially participate in the global economy very quickly. And we're supported in 25 countries. So it's not that straightforward. Like depending on the country, the payment method that you use, where your customer is based and where you're based, the answer is actually quite different. I'm happy to try to reduce it down, but just as a disclaimer, it's actually pretty complicated just because we can do so much more than your typical payment processing company.
Yeah, sure. So please do reduce it down to whatever level of abstraction works for you.
Great. So the way we think about Stripe is we provide a set of composable products up and down the stack. To start, there's an option for one of our users to figure out, how do you want to accept payments? Do you want to build against our API directly so that you maybe are setting up your own backend, you're sending a request to Stripe API that kind of bundles up charge data and sends it directly. On the other hand, you could also choose to integrate against our different front-end components. You can choose checkout, which is a full web page that enables, we just serve an entire web page for you, your users just type it in, and we handle everything from there. Or you can do something in between that's using a set of front-end components. But essentially the idea is a developer would choose the way they want to integrate with Stripe, expose something to their user to collect payment information. Stripe actually handles the tokenization and secure. We basically are able to store all the sensitive data securely so that our end users never have to actually touch the sensitive card data or enter PCI scope. We handle all of that. We receive, let's say, a request to process a charge. Depending on the payment method, there are different ways that this can happen. A typical credit card transaction will just happen synchronously. So we'll send a request in the back end, basically authorize the charge and kind of give you a response one way or another. Was it declined? Did it go through? What was the value? For some payment methods, they can either take you through a redirect flow, or maybe it's a more asynchronous transaction like a bank debit method. From there, we have this transaction on Stripe. What's great about our product is we handle kind of all the complexity in the back end. So we'll take care of getting the money into your account and potentially, taking care of currency conversion or moving it into different accounts that we have on our end. What the user sees is just kind of this transaction log. You can look at what are all the transactions, what happened to it, when does it land in my balance, and when do they get paid out. But there are lots of different ways that we can help you configure that as well. One example is our marketplace product called Connect. So that enables you to actually have a few more options on how you kind of handle that transaction. So one example is Lyft, where it's not so straightforward. As a passenger on Lyft, you take a ride and you obviously are kind of paying Lyft, but you're paying for a service by a specific driver. So what Stripe helps Lyft do is both kind of model that transaction as a Lyft charge for driver Bob, and kind of representing that transaction as both a transaction for Bob, but also for Lyft. And we kind of help you reconcile that on the back end and also get the driver paid out very quickly.
So from an engineering perspective, one thing that seems luxurious about working at Stripe is that the products that you're developing, the typical user is a developer. And at many companies, you're developing a product that is not targeted at developers. I know Stripe is not explicitly and only producing products for developers, but the vast majority of the users are developers. So you can assume a high level of kind of technical willingness, but also there is a focus on simplicity so that you kind of have this sweet spot of product development. And also, the fact that you're building products for engineers and you are an engineer yourself, it becomes a little bit easier to empathize with the average user as opposed to if you're building a product for the general populace, So I'm wondering how that affects product development and engineering from your point of view.
Yeah, I think one thing is Stripe definitely started as a very developer-centric product. And I think it shows in a lot of our documentation and the product itself, the API design, and even how our dashboard is designed. But over the years, I would say that while we are a great product for developers, we also have users of many different kinds. And you alluded to this. I think we also think of the example I just gave. We also think of the Lyft driver as a Stripe user in many ways because they are providing a service that we're able to help them get paid. So I think we have actually a pretty diverse range of users. So when it comes to product development, I think what we've done is we tend to start with a technical foundation. Like you said, it's very developer-centric, it's very composable, but we do from day one keep in mind how a variety of users might use it. So one example is earlier this year, we launched a big refresh to our recurring billing product called Stripe Billing. And we started kind of like first principles, like developer-centric. We designed a set of easy building blocks in the API that kind of interop really well. We made sure they integrated well with existing objects. So we added a few new ones, but we also looked at some of our oldest API objects like customers and made sure they worked seamlessly with recurring billing. So that was the foundation. But we also know that, there are a variety of types of recurring business owners and users who may not want to immediately go to code and might want to test out one subscription plan or like one new kind of invoice or one product. And so from day one, we invested a lot also in building dashboard tools. And we found that the dashboard tools maybe are serve kind of dual purposes. They help users that aren't maybe just developers use the product very early, but they can also help developers test things out quickly and get started. And sort of we've kind of gone on from there where even on top of the dashboard tools, we're building higher level products. So, you maybe can automate kind of invoice delivery and conversion without writing any code. So I think we are kind of moving up the stack over time, but we never lose that technical foundation.
When you build a payments API, you're abstracting away from the developer things that a developer doesn't want to have to think about. So I've been kind of trying to understand the payment rails of the online economy a little bit recently in some recent shows, and it's a little hard for me to understand. It at least feels in some ways foreign. It's you've got these things like credit card processors or I guess I should say credit card companies. You've got banks, and the minutia of the life cycle of a payment as it goes through those parties is not necessarily intuitive to a developer. I think, at least it's not intuitive to me. And I'm imagining that my payment, when it goes through Stripe and under the covers, it's making its way through like COBOL code and some weird old legacy infrastructure on the side of the credit card processors or on the banks. How much of that stuff, as an engineering manager at Stripe, how much of that stuff do you have to understand? Do you have to kind of like know the guts of the the legacy? Do you have to unearth the archaeological dig of the payments of the past?
Definitely. I think what's interesting about Stripe is how we can abstract that away from users. So, let's say you're integrating with Stripe, you don't need to do that. And we actually so our efforts are sort of twofold. On one hand, on the product side, we actually invest a lot in designing APIs that really try to abstract that away for external users and internal ones. So one example is our payment method API, V1 sources. And what we try to do there is we take a range of payment methods that have different minutiae like you described. So settlement timing or refund dynamics, things that are very kind of spec specific. We actually try to reduce them down to an internal API that kind of simplifies it. So there's a source of money, there's a receiver of money, you can adjust the timing and so forth. And we try to build that internally as well. So some teams can actually work on top of that in the same way, and they benefit from that clarity and simplicity the same way external users would. But of course, you go lower in the stack, and there are teams at Stripe in payments that really do have to understand the nuts and bolts of the specs and exactly what's happening with our financial partners and how we participate in the network. So you will have some teams at Stripe who will read Visa specs and kind of really try to understand what the latest is in what our financial partners are doing and how to think about the different interactions of payment methods. But I think we try to take an approach so that not every engineer in payments needs to understand exactly how the Visa spec works. And we try to build various different layers of internal infrastructure to make it easier and easier to understand kind of higher up the stack you go.
So when I accept a payment online, maybe it comes from a credit card or an automated clearinghouse payment or Alipay. Depending on the payment, what's the acceptance process look like on Stripe's end, like from an infrastructure perspective? So is it hitting some kind of monolith? Is it hitting some like payment identification gateway and then it like tees off to the Alipay processing system or the credit card processing system? What's that service to service communication sequence look like?
It kind of mirrors what I just described. So there's essentially an API layer, like an internal API layer. So we might receive, a bundle of data for a specific transaction, and we'll see, is it a card? Is it a Alipay transaction? Is it a bank debit method? And there's kind of a layer internally that we think about with cards and sources. So kind of the same thing I described. We call it V1 sources externally, but we also have sources served internally that knows how to process different payment types. So I would say there's sort of a mirroring of the outside. It kind of makes it into our API. We'll have different code paths or even different services depending on the type of payment method. And then it kind of goes down from there. So yes, it varies very widely. There are some payment methods that, may go to even different partners on the back end, depending on the country, payment method, and payment method type.
And do you have to identify like the latency of the different payment providers in order to figure out like what how to think about the external dependencies and what you're going to make asynchronous, et cetera? What are the challenges of integrating with the various external dependencies?
So I think kind of the same that would apply to just any maybe product that has to manage a lot of external integrations. I think there's some amount of having an internal sense and reconciliation of what do all these external APIs look like. Again, we take a very kind of scaled infrastructure approach. So let's say, a set of our partners, typically there's a lot of async batch filing. So we might aggregate transactions into a batch file, which we send kind of over the wire to specific partners. And each of them may have a different spec. So they might require different fields and different orders and so forth. And what we've done is we have to understand that, of course, in order to give them the correct data. But we also try to abstract that internally. So we can build an internal sort of batch infrastructure, sort of API translation layer, so that we can kind of scale and more easily plug in new partners.
Cloud computing can get expensive. If you're spending too much money on your cloud infrastructure, check out Do It International. Do It International helps startups optimize the costs of their workloads across Google Cloud and AWS, so that the startups can spend more time building their new software and less time reducing their cost. Do It International helps clients optimize their costs. And if your cloud bill is over $10,000 per month, you can get a free cost optimization assessment by going to doit-intl.com/sedaily. That's doit-intl.com/sedaily. This assessment will show you how you can save money on your cloud. And Do It International is offering it to our listeners for free. They normally charge $5,000 for this assessment, but Do It International is offering it free to listeners of the show with more than $10,000 in monthly spend. And if you don't know whether or not you're spending $10,000, if your company is that big, there's a good chance you're spending $10,000. So maybe go ask somebody else in the finance department. Do It International is a company that's made up of experts in cloud engineering and optimization. They can help you run your infrastructure more efficiently by helping you use commitments, spot instances, right sizing, and unique purchasing techniques. This to me sounds extremely domain specific, so it makes sense to me from that perspective to hire a team of people who can help you figure out how to implement these techniques. Do It International can help you write more efficient code. They can help you build more efficient infrastructure. They also have their own custom software that they've written, which is a complete cost optimization platform for Google Cloud, and that's available at reoptimize.io as a free service if you want to check out what Do It International is capable of building. Do It International are experts in cloud cost optimization, and if you're spending more than $10,000, you can get a free assessment by going to doit-intl.com/sedaily and see how much money you can save on your cloud deployment. The fraud detection and risk mitigation process is core to every payments company that I've talked to, every e-bank or challenger bank that I've talked to. They spend a lot of time thinking about fraud and risk. And I did a whole show with Michael Manapot, I think it was a year and a half ago or so, where we talked about that. We talked about radar and the data engineering and the data science behind that. And I think organizationally that product set falls within payments. How much time do you spend thinking about fraud and risk? And what's in terms of the hierarchical management structure, how does that interaction between you and Michael, for example, or you and the risk team, where's the kind of the partitioning of responsibilities there?
Yeah, I work very closely with Michael. I think one thing just to say is we've been growing extremely rapidly over the past few years. I think it's something that's been incredibly exciting to see. So Stripe, when I joined, was just over 200 employees, and today we're over 1,000. And that means we've also had to scale our engineering org in a variety of ways. So I guess what I'll say is I actually don't think the way the org is necessarily structured is that important in any given point in time. It's really how teams work together and how do we build shared metrics, shared goals, and shared interfaces. I mean, to answer your question, I do work very closely with Michael, and actually quite directly, given how important and central fraud is to payments. But I'd say the way we think about kind of what you described, how do you think about risk? So I think we think about payments from a very product-centric view, where, as I described, we have this kind of layer of financial infrastructure, we have internal abstractions, we have different product verticals, and that's kind of how we set things up. And we also, Stripe is an incredibly, in a very exciting way, very cross-functional, very collaborative. So when you think about how does risk work with payments, we have shared missions, we have shared goals. So we might, together look at fraud and risk metrics across the company in the shared meetings and set shared goals.
I don't know if you've ever seen this diagram of the different company structures where they have the graphical structure of the company and the hierarchical structure. And you take Amazon, it's like a binary tree, and it's two people answer to the top person and two people answer to each of those people, and you know exactly who is your direct report and who you are reporting to. Then they also graph Facebook, and it's like it's a completely directed acyclic graph. It's supposed to be modeled as completely decentralized. And I always, the set of graphs is always stuck in my head as something I study, because companies are successful with different org structures, and you also see these different org structures break and fracture with different volumes of employees. So can you give me more of a perspective for how Stripe organizationally, as you're growing, I'm sure you're having these kinds of conversations, how hierarchical you want to be versus how decentralized and flat-ish you want to be?
I've definitely seen that graphic. It's pretty funny. So I think that's actually very reductive, but I think we do think a lot about how we scale across engineering teams and how the structure, should be. I think in general, I've spent a long time in my career working on scalable infrastructure and scalable platform products. And I think scaling an engineering org is very similar. So you want to be pretty responsive to changing needs of the organization, but you also want to be pretty honest and take a look at what's working, what's not, and iterate on it as you grow. So I would say Stripe tends to be a pretty kind of, I would say an empowered, fairly, in some ways decentralized from a hierarchical perspective. It's not like we have, very, a very deep tree or anything like that. But we actually, the idea is for each engineering team, what is the mission? What is the goal? And how do they work together with the teams around them is kind of the highest order. We also think a lot about healthy growth and reliable and scalable growth. So we think a lot about when we look at a certain structure, what are the challenges with it when it comes to how it impacts the business? It's hard. I'm sorry. It's a little bit hard it's hard to answer your question because I don't think we really fit one of those diagrams.
I want to say, by the way, I think that's fine, because also taking overfitting on the past companies or companies that are still thriving today with their internal org structure that they developed 5 or 6 years ago, it's you can't closely fit your organization to it. partially because there have been innovations since then. We didn't have Slack widely accepted 10 years ago. We didn't have Asana widely accepted, or I don't know what your project management system is, but Asana is a little bit different. And, you could argue Twitter is like a collaboration tool that everybody's on. And it's like things have changed. So you sort of have to reorient yourself in time. There's a lack of precedent to orient yourself on.
Actually, that's a great point. And so maybe what I would say is what characterizes our engineering or growth, I would say, is being flexible to change. So as we've grown, so I mentioned, I've seen the company already grow from 200 to 1,000 and just super excited for the growth we have ahead of us. And something we've done is continuously iterate and kind of adjust for scale. So I can think of a few examples. One example is when I joined the company, as you mentioned, we had a very API developer-centric product and culture. So we had a lot of API generalist engineers and had relatively few front-end specialists, relatively few kind of machine learning specialists. But as we've grown, and as a result, we had a very centralized front-end team. We had a couple front-end engineers who would support the front-end products, and they were just sort of on their own team. But as we grew, we saw that we needed to scale. We were building many, many more front-end web products. And so we started building a front-end hiring pipeline. We started forming a larger and larger team. And when we saw that scale, we realized actually it made more sense to have front-end engineers embedded closer to their product areas to, as I mentioned, kind of better group around the mission and goals and the business impact that we were trying to have. So today we actually have front-end, dozens of front-end engineers that are throughout the engineering org embedded in different teams. But just 2 years ago, we had only one centralized team. Another example that's very top of mind for me that kind of demonstrates this flexibility and scaling mindset is our approach to global expansion. I think for a long time, we would have, people on larger teams focused on global expansion. So within, let's say, a part of our financial infrastructure stack, we might have most of the people working on just shared infrastructure or scaling out maybe our largest partners, and we have a handful sort of integrating new international partners. And that worked and for a long, long time. But as we've seen today with our very ambitious global expansion goals, we've actually broken ground on not only having a more dedicated engineering team for global expansion, but we've actually, for the first time, set up an engineering office outside of the US. And just earlier this month, we kind of sent our initial landing team to Dublin to kickstart global engineering in a much more decentralized, distributed way of working.
Do you also rethink the roles? So like the traditional set of roles at an organization that makes software technology products is like program manager, project manager, maybe QA person, manager, like designer, software engineer, SDE2, SDE3. It's like a menu. You go to a McDonald's and it's always the same menu. And there's certain companies where it's like they're just going to copy that model, and that model works in many ways. But I feel like there's maybe a bit more subtlety to the roles at Stripe. Like Stripe is obviously design first, for example, which it's kind of curious, like the whole design and the focus on design and developers, even though like an engineer, typically when they're working with an API, it's like, okay, what matters to me? It's the design of the API. Like, is it a nicely formed JSON object? But actually, like developers care a lot about the visuals too, which is an underestimated thing that Stripe has kind of taken advantage of. So yeah, role fluidity. What do you think about roles and new roles? Should people have these very traditional distinct roles like program manager, or or is there something different, more subtle?
Well, it's something you were saying earlier. I think the broader just ecosystem or tools that we can use in software engineering are continuously evolving and changing. So one thing comes to mind is even 5-10 years ago, you would have large teams of people who would manage data center operations, right? And today, that's just not a skill set that Stripe needs. We build on the cloud. So I think, as you're saying, as these different productivity tools or even just different software paradigms emerge, roles will naturally need to evolve and change. But I think Stripe is unique in this regard because I think we really push for a flexibility and an adaptive nature of our engineering team. So what we have is we have a really strong culture of internal mobility. We've actually had engineers move from infrastructure kind of security teams into core product teams and vice versa. We've had people move from, more like front end to back end, mobile to AI and so forth. And I think that kind of shows that the growth mindset that we have. It also, I think, creates a really interesting and sort of strong engineering culture because it feels like people can learn and they're not pegged into very, very specific roles. So, for example, we actually just have a software engineering track today. We don't really have some companies, like you said, sort of go off the menu and they might have DevOps engineer, site reliability engineer, like these different sub flavors. But for us, we really believe in a unified kind of very strong engineering culture.
What about the constraints? What constraints do you want to put on your teams, the engineering teams? Obviously, the fluidity is great, but you probably don't want every programming language. You don't want people writing code in some COBOL, like in Stripe. You don't want to give that level of freedom. You probably want to standardize on a continuous delivery tool, or maybe not, because there's so many of them today. But you want to standardize. If you're on AWS, at least, I don't know if you're also going multi-cloud with Google. But do you have like platform engineering? Do you have standards, the constraints that you put on developers?
I think we definitely believe in investing a lot in developer tooling and productivity, and I think that's where the standards that you might come from. I don't know that we think about them really like limitations. I think it's really kind of the flip side. Like, what can we do to help people move faster? And in the same example, like, in some cases, adding a new language to build one new service is not the fastest path to kind of getting impact, right? So I think we have a very users first kind of impact driven environment. And that's where a lot of our decisions come from. I think the reality is, we do believe it's faster in many ways to use kind of existing languages or existing infrastructure or kind of the way that we set up certain services that enables, if a new team coming along, enables them to get up and running much more quickly. So that there are some standards that kind of emerge that way, but they're mostly driven from the end result and not from a kind of like a limitation or a restriction.
That's great. So you don't have to do these are the 4 blessed languages that you may use at Stripe. You don't have to do that kind of thing.
I mean, we've talked about that a lot, but in the way, I think, let me put it this way, even if let's say today we have a few blessed languages, I think if there was a new business need that we learned about that made us rethink that and said, hey, we actually, let's say we're using Ruby a lot for this, but this problem is just so different. We need to use a different language. We would totally do it. And in fact, this actually happened earlier this year. We acquired a company that does point of sale products that we're really, really excited about. And if you can imagine, like, point of sale, there's a hardware component. There's, so many different things that are very different from processing just online payments. And that has pulled in a few different languages, a few different technologies, because we see that it's going to make a meaningful difference in the quality of the product.
What are they using for the hardware?
So C++ is a lot of the kind of on the embedded side, and Java and C++ are the sort of main languages. I think we are still kind of working on integrations there. Interesting.
Yeah, and that company, that was not like a super old company, right? So I'm actually kind of surprised they use C++ instead of like Rust or Go, or maybe there's something about embedded systems that you still want C++ for.
I think a lot depends on the partners and how you're working with partners. In some cases, you're just integrating against building SDKs or integrating against partner software. So there's some amount of just working with the ecosystem that influences some decisions there.
Are you standardized on any? I mean, I know you're standardized on AWS, but has there been any desire to I want to be on Google because of GKE or because of the BigQuery or something? Is any desire to go multi-cloud for particular APIs?
I think kind of the same principles applies. We're always looking and we always are keeping up with the latest and trying to see what's out there, because if there's an opportunity to, meaningfully improve the quality of our services or our product, we might do that. So I would say we're always looking and learning, but that's probably the main thing.
I actually have a question. It's not really super related to engineering, but more about like business level productivity. So there, we talked about Asana and Slack earlier. There's these other business software tools, things like Front and Airtable. I see these companies raise a lot of money, and so I assume the tool is pretty useful. And I'm actually tempted to, try out ditching Google Sheets and trying out Airtable and seeing what it does. I guess I haven't been tempted enough to actually try it out. But what do you think of this next generation of business productivity tools. Does that affect your engineering at all, or do you see those being used at Stripe? Do people experiment with those?
I have a lot of personal interest in tools, software tools, and so I play with a lot of them for my personal projects. I think for Stripe, again, our main focus is really building the best products as quickly as we can and maintaining a high level of quality. So I think it kind of goes back to that. Like if a tool for some reason we saw would have a meaningful and cause a meaningful improvement to our productivity, we would explore it. And we've done that. We've kind of upgraded various things we use internally, but I don't think we have an objective of just kind of playing with tools or really trying to find the next best one.
Failure is unpredictable. You don't know when your system will break, but you know it will happen. Gremlin prepares for these outages. Gremlin provides resilience as a service using chaos engineering techniques pioneered at Netflix and Amazon. Prepare your team for disaster by proactively testing failure scenarios. Max out CPU, black hole, or slow down network traffic to a dependency. Terminate processes and hosts. Each of these shows how your system reacts, allowing you to harden things before a production incident. Check out Gremlin and get a free demo by going to gremlin.com/sedaily. That's gremlin.com/sedaily to get your free demo of how Gremlin can help you prepare with resilience as a service. Have there been any particular tools that have been exciting to you that have come out recently on the engineering front? So like maybe there's a CD product or some new API that came out that's solved some problem. Is anything or some new AWS service or anything recent that's really taken you by surprise?
I don't know that we have. I don't think this is something that actually exists, but something I think a lot about is how we're going to scale and expand globally. And so I see there's a lot of conversations happening now with major cloud providers about how can they successfully help people expand globally with a higher level of security, data encryption, data locality. So I don't think there's actually anything out there yet, but I'm definitely kind of on the edge of my seat wanting to see what happens there.
Yeah, this is an interesting problem because I think I talked to somebody who was talking about going multi-cloud or going across the world, and they're trying to like replicate a Kafka cluster across the world, and that's hard, right? Like replicating a really big distributed queue across the world. I don't think that's a solved problem.
Yeah, definitely.
Are there any particular engineering pains around going international that you've found problem as, like latency or replication? What is it exactly that makes international hard?
I definitely think latency, things where you've made an assumption about being in one location and it permeates your product, that makes it really challenging. I would say another is just local. The world is quite fractured when it comes to payments worldwide. Like regulatory concerns, compliance restrictions, they're just very, very different. So something we've seen is in the same way that engineers might have to deeply understand visa specs, when we enter a new country, we have to really understand what are the requirements there? How do the local payment methods work? What are the different terms and what is the payment experience like for users? And that actually ends up being probably one of the hardest things. Like one example is with 3D Secure, which is a kind of new, essentially payment standard that tries to increase the security, reduce fraud in Europe. I would say from a US-centric view, we think of credit card payments. You type some things in, you click send, and it kind of, you actually want a faster process. You want it to work quickly. You just want to get through your shopping cart. But for European users, they're actually accustomed to a heavier weight flow. It might redirect them to another site so that they can better authenticate it. And for that audience, that redirect and that heavier weight flow is actually better because it increases their confidence in the merchant and in the product. And so that's something that's really hard for us because on one hand, we're trying to make our front end flows maybe really fast, really efficient, really high quality for certain users. But then we're like, actually, they want a more kind of intense, like redirect based, multi-step process. So those kinds of things can be very challenging.
And then in India, you have the cash on demand thing, right? Is that something Stripe has tackled?
We have not been. We're not working on that right now. I would say it's something that we're learning a lot about. it's not just India. I think many countries in emerging markets in Southeast Asia and Africa, cash is a huge component of their of payments. And I think that's just something we're learning a lot more about and thinking about how to support.
Yeah. So what are the problems of how would you make have you like batted around this idea? Like, how can we make an API for cash on demand?
Actually, so what's interesting is I think, as I was saying, I think we think a lot about how do we build common infrastructure kind of tools and language around payment methods. So, as I mentioned, we are building a lot more in card present, supporting card present. And there's something very analogous there. You have a different payment method. There's something that happens in the physical world that you have to do. And then the kind of killer feature is how does that integrate seamlessly into your online business? And so we do think about that a lot. I think it kind of is APIs are sort of the answer again. You maybe have some API layer, which we provide through V1 sources and kind of our charge API that enables you to give us data somehow. And what's great about Stripe is in the back end, we can use that data, create a canonical view of your business. And I think cash is no different, or paper checks, or like many of these different methods that seem kind of older school. In the end, it's really a bundle of data that you're trying to kind of give to, you're trying to move the data from a customer to a merchant. And in the end, the merchant just wants to get the money at the other side of that. So I think they're actually very common. And I think something that's really exciting that we do is we really try to reduce these complex problems down into something that kind of more simple and more composable.
I did a bunch of shows about cryptocurrency stuff a while ago, and one thing that the cryptocurrency stuff boils down to is uncensorable payments. That's what that's one thing that people really value out of the blockchain. Like whether that is actually possible right now is up for debate, since the ledger is kind of centralized, I think, in some particular mining organizations that could actually do a 51% attack if they wanted to. So it's an open question as to whether you can actually have uncensorable payments today. But conceptually, that's what cryptocurrency companies want to be. Now, censorship gets a bad rap, but in some cases, you might actually want censorship. You might want certain types of organizations or certain types of businesses to be, quote, censored, if for no other reason than to adhere to government standards that oversee a particular type of business. A business in the United States, you for example, you can't have an API for, name your miscreant behavior. That's, at least that's not on the blockchain, or that's, under scrutiny like Stripe. So how do you think about the correct level of what to allow through Stripe's API?
Yeah, I think the short version is the teams I support. We really think a lot about building APIs for kind of collecting information and processing payment and kind of supporting transactions through Stripe. I would say there is another team that thinks a lot more about policy. So I would say that's like risk compliance, and I do think that's actually like a really interesting topic, but I'm probably not the best person to speak to that.
So Raylene, you've been at Stripe for 3 years. How has your job changed in that period of time?
Really quite a bit in many ways. I'd say, as I mentioned, it's just grown a lot. So I think when I started, the product team that I led, it was really interesting. We had one product team that built all of our products, and it was maybe 15 people, and there was one product manager started the same day. It was a very lean team. I would say over the few years, we've had to scale that up, and we've launched many, many new products, and we've grown the engineering team considerably. So I'd say the way that I spend my time day to day has changed a lot, but also just like kind of the demands of the engineering org and our different areas of focus as a company have also evolved.
So as a manager in a perfect world, if you were doing things by the book, you would kind of want to delegate everything. You want to spend as much time as possible thinking about higher level concerns. But there are managers that I've talked to that have emphasized the importance to me of occasionally signaling that you're capable of doing lower level work. So for example, you're capable of writing code. How do you look at that kind of signaling? Do you look at that as important at all? Like kind of signaling that you're a manager, you're an engineer too. You're not just a manager. You're willing to dig into the code, or do you feel like that's totally beyond your purview and that should be abstracted away from you?
I think you used an interesting word, the word signaling. So let me kind of share just my take. So in my first 4 to 6 weeks at Stripe, I actually did write some code. I pushed a small change to like the way we displayed fees in a certain region of the world. I wrote some code. I got familiar with the dev tool chain and really wanted to deploy some actual production changes to our users. But for me, it wasn't important from a signaling perspective. Truly, it was about building kind of empathy and some very personal understanding of what the day-to-day looked like for an engineer at Stripe. And I think there's a tremendous amount of value in that, but you can get it in different ways. So another recent example is I wanted to get a feel for what does it look like to be kind of on our weekly on-call rotation. And I don't think it necessarily is, better for anyone for me to actually kind of be trying to debug issues in real time for our users, but I did want to see what it was like. So I shadowed an engineer and I sat next to him and kind of watched as he went through very specific workflow details, like checking on specific bugs, like examining the code and so forth. And I think for that can provide tremendous value as an engineering leader, because ultimately in the end, I think you're trying to support the health and happiness and productivity of your team, but you're also trying to represent to others, like, what are the critical problems? What should we be doing to help the team? And I think it's hard to do that without some degree of detailed knowledge, but I don't think as a signaling or symbolic value, it's that important.
Okay, cool. Well, just to wrap up, what is something that you know about engineering management today that you wish you knew a year ago?
I think I've learned a lot about adaptability. I actually think that's something I've thought about throughout my career, but in particular, in the last year, there's just how applicable adaptability is to a really wide range of problems and teams, I think is what I've learned. And so I think it's kind of, as we were saying before, things are always evolving in the world around you and day to day within your teams. And so there's something around, as an engineering manager, learning to kind of adjust to change, kind of almost actively be a kind of participant in thinking about how to evolve your team to the next chapter. I think that's incredibly, incredibly important, particularly in high growth environments where you just have to understand that things are going to be different in 3 months than they are today. And I think the best engineering managers and leaders are able to kind of not only be okay with that change, but to actively anticipate it and kind of design everything around this idea of adaptability and scale.
Okay. Well, Raylene Yung, thank you for coming on Software Engineering Daily. It's been great talking to you.
Thanks for having me.
GoCD is a continuous delivery tool created by ThoughtWorks. It's open source and free to use, and GoCD has all the features you need for continuous delivery. Model your deployment pipelines without installing any plugins. Use the value stream map to visualize your end-to-end workflow. And if you use Kubernetes, GoCD is a natural fit to add continuous delivery to your project. With GoCD running on Kubernetes, you define your build workflow and let GoCD provision and scale your infrastructure on the fly. GoCD agents use Kubernetes to scale as needed. Check out gocd.org/sedaily and learn about how you can get started. GoCD was built with the learnings of the ThoughtWorks engineering team, who have talked about building the product in previous episodes of Software Engineering Daily, and it's great to see the continued progress on GoCD with the new Kubernetes integrations. You can check it out for yourself at gocd.org/sedaily, and thank you so much to ThoughtWorks for being a longtime sponsor of Software Engineering Daily. We're proud to have ThoughtWorks and GoCD as sponsors of the show.
Wow!